By the end of this module, a menu will float in your room and you will press its buttons with your finger. This is how the people who use your app actually control it from inside VR. Start a sound. Change the lighting. Reset the scene. All from a panel in midair. User interface in VR is different from anything you have built before. There is no mouse. There is no flat screen in front of you. Your menu lives in 3D space, floating in the room, and the user reaches out and touches it. A button is not something you click. It is something you push with your actual finger. Once you see UI as a physical object in the room, it all makes sense. The core building block is the world space canvas. In Unity, a canvas is where your buttons and text live. Normally it is stuck to the screen. In VR, you set it to world space, and now it is a real panel you can place anywhere in the room like a floating tablet. Everything you put on it, buttons, labels, sliders, becomes part of your 3D world. How do you press a button that is floating in the air? With Poke, the same idea from the last module. Your fingertip becomes the cursor. You reach out and push the button inward, and it presses. The Meta XR SDK gives you a Poke interactor on your hand, and you mark the panel as pokeable. Now your finger just works on it. Let us build a simple panel. You create a world space canvas, give it a background, and add a button and a label. You place it about an arm's length away, at a comfortable height, tilted slightly toward the user. You size the buttons big, much bigger than on a phone, because fingers are less precise than a mouse. The lab guide has every exact step. A button is only useful if it does something. In Unity, every button has an on-click event. You connect that event to an action. Press Calm and a soft ambient sound fades in. Press Energize and the lights brighten. Press Reset and the room returns to its start. You describe each action to your agent and it wires the button to the code. A few design rules keep your VR menus comfortable and usable. Make targets big and well spaced, so fingers do not miss. Keep the panel about an arm's length away, not in the user's face, not across the room. Use high contrast and few words, because reading in VR is harder than on a screen. Comfort first. A menu that strains the eyes or arms will not get used. Now let your agent do the heavy lifting. You say, make a floating panel with 3 buttons, Calm, Energize, and Reset. Calm plays a soft ambience, Energize brightens the lights, Reset returns the room to start. Make them pokeable with my finger, and place the panel at arm's length. The agent builds the canvas, wires the buttons, and tells you exactly what to attach. A few traps to know. If your buttons will not press, the panel is usually missing its pokeable setup, or it is too far to reach. If the text looks blurry, your canvas resolution is too low, or the panel is too small. And if the menu chases your head around, it is parented to the camera. Fix it in place in the room instead. Tell the agent what is wrong, and it walks you through the fix. Think about what a menu unlocks. Settings. Mode switches. A start screen. A pause menu. A way to choose what happens next. This is the line between a tech demo and a real app. A demo just shows one thing. An app lets the user decide, and your floating panel is how they decide. You just gave your users control. So here is how to use this module. This video is the map. It shows you the UI model and the design rules. The lab guide beside it has every exact step to build the panel and the prompt to wire the 3 buttons. Watch this once, then open the lab guide and build your floating menu. That is Module 4. Your app now has a menu the user can reach out and control. Next module, we bring it to life with sound. Spatial audio that comes from real places in your room, so a chime sounds like it is truly coming from the stone you just touched. Open the lab guide. Let's build your menu.